Yo, what is up YouTube? In this video, I'd like to teach you my favorite method of circuit analysis. It's called superposition. So there's a couple basics that we have to go over first. With superposition, you go through each source, so for each source, disable all other sources, and then solve for your voltage or current of interest. So in this case, we're going to look at Vx. So if we disable all their sources, if we have this guy, that means we want to disable this guy. If we want this guy, we disable this guy. Now what you do is you superpose, which just means add up those voltages and current contributions from each source. So let's go ahead and solve this circuit if we disable the current source, so solving for the voltage source. Oh, another note here, up in this top right corner, these are some important assumptions. So if we say that current going through is equal to 0, that means that there has to be an open circuit. And if the voltage across is 0, then you know it's a short circuit because the voltage from here to here is 0. All right, so let's go ahead and write this circuit with only the voltage source. So here we have plus minus 15 volts. Then we have our resistor as normal, 5K here. We have another resistor, 10K. We have a resistor here, 4K. And then this current source, we set it equal to 0, so we know it's an open circuit. Now, since there's no current flowing here, we don't have to care about this part of the circuit. And our circuit reduces to just our 15 volt supply, going through 5K, and then going through 10K. And remember, we wanted to solve for the voltage at this node. So we'll call this Vx, and then I'll subscript that with a V. So the contribution to the voltage X from only the voltage source. So this is a simple voltage divider. So Vxv is equal to 10, the resistor of interest, over the total resistance, which is 15, multiplied by the source voltage, which is 15. So we cancel this, and we get Vxv is equal to 10. Nice, so we have the contribution from the voltage source. Let's take a look at what the contribution from the current source looks like. So I'll draw this current source here, 1 milliamp. We've got a resistor coming this way, 4K, and then we got a resistor coming down here, 10K, a resistor over here, which is 5K. And then this voltage source is set to 0. And remember, 0 volts is a short circuit. Connect that all up. Now what we can do here is simplify this circuit because what we're trying to solve for is Vx from our current source. So I'd like to add these two guys in parallel. So 5 in parallel with 10 is equal to 5 times 10 over 5 plus 10, which is 15. This is equal to 3.3 K. So what we have here is 3.3 K, 4K, and a current, 1 milliamp. And remember, we want to solve this Vx from I. And remember, this is positive here and negative here. Note that the current direction is going like this. So it's going to enter the negative terminal and leave the positive terminal. So we're going to have a negative voltage. We're going to have, this is 0 volts here. This is Vxi here. So you have 0 minus Vxi over 3.3K has to be equal to the current 1 milliamp. And this means that Vxi equals negative 3.3 volts. So this means that the total voltage Vx equals Vxv plus Vxi, which is equal to 10 minus 3.3. And that gives us 6.7, I think. Let me double check that with the calculator. Yep. So we got 6.7 volts right here from here to here. Awesome. Thanks for watching this video. Have a wonderful day.